Hi there, welcome back here. In the previous lecture, we have been talking extensively about the stack, about the memory, how the functions are executed. In this lecture, I would like to give you a few examples so you can practice this, or maybe you can imagine it better. Okay, so here I have a file called examples.rs. You can find it in the resources of this lecture, or if you want, you can also create examples.rs and you can write this down. It's actually very simple. So here's a main function executing function c, d, f, and here are the functions a with this body. Here is the b print lining c, d, e, f, but again, if you want, you can just simply copy paste it from the resources of this lecture. You can find their GitHub repository and you can copy this functionality, or you can just write it down. It's very, very fast. And now when you have it, you can just simply copy the entire this functionality. You can go to main.rs and you can override it. Okay, just for now. And now, without any running of the code, you can tell me what will be the print lines, what you will see in your console, in which order. Okay, so what print line you will display first, and what will be the next one, and what will be all of them when you will run the main function. Okay, you can think of it. You can take a look on this, and you can run it. Okay. So terminal, clear it out, and the cargo run, and the console logs will be in this order here: C, D, A, E, F, and the B. Now, if you want, you can draw the stack and also specific stack frames like this on the paper, or maybe you can just watch as I will be moving them to the stack, so you have a better idea what's happening. Okay, so I will be switching between here and between here. Okay, so first, the main function will be executed. Okay, that's the first thing what will happen. Always the main function will be executed. I don't have here proper indentation. I'm sorry for this. Okay, don't mind it now. Okay, so main function is executed, so main function will be moved on the stack. Okay, in the main function we are executing function c, so we'll find function c, so this function will be executed now. So we're putting this function on the stack. Okay, and the first console log will be the c, right? So c will be print lining calling c, so the c will be the first output. Okay, so what's the next? So after C, okay, so C is finished. Okay, so C has finished execution here. You can see there are no additional lines of the C, so C will be moved out of the stack and will be getting back to the main function. So now the C will be going back, a little bit back here, and we are back on the main. Main is on the top of the stack. Okay, now we are executing D here. Okay, so now the D function, and here we are printlining now D. So you should see the D now. Okay, and we are printing out D, and now the two Ds are put on the top of the stack. So let's get the D. D is put on the top of the stack. And as you can see here, the D is not the last instruction here. So from the within of the D, we are calling the A. Okay. So here we are calling the A function. So A function is here. So now we should be print lining calling A. Okay, so here is a calling A, and we are putting the A on the top of the stack. Okay, so we are putting A on top of the stack, and remember the D is still here. Okay. Okay, so we are putting A on the top of the stack, and as you can see here, on the A we already called it, and we are calling also E from within of the A. So we are going to call E, and we are printing out now E. So in the terminal you should see now E. Okay, so we are printing out E. This means that E is loaded on top of the stack. Okay, so E is loaded here. Perfect. Okay, so let's take a look now. So after E is executed, we have a print line here. There is no other instruction. So this means E is loaded outside of the stack. Okay. So there is nothing else to execute. So E will be loaded back here. Okay, then we will previously we are now the stack pointer moved from the E to back to the A function. Okay, so we are going back to A function because it's currently on top of the stack. We are going back here where we have finished when we have executed E function, but there is nothing else here. There are no other instructions, so A can be also moved out of the stack. Okay, so we are moving also A out of the stack. Okay, so we are going back. The stack pointer is moved back to now to the D function. Okay. So now we are going back to the D function. As you can see here in a D, after we have moved back to the A when we have executed it, so there is no other instructions after A, so this means that the D can be also placed out of the stack. Okay, so D can be also placed out of the stack. And now you can see we are back to the main, so the stack pointer is pointing now to the main, so we are going back to the main function. We are back where we have started, where we have executed the C function, right? So after the C function, what happened? We are executing the D function, right? So the D function here, or actually, we have been finished in a D function. My mistake. We are calling now a F function. Okay, so we are calling the F. Okay, here we are here on the F function. I almost messed up. Okay, so we are calling F function. It's loaded on the stack, and we are calling F. Okay, so you can see we are calling F, and the F is loaded on the stack. Okay, so now the F is loaded on the stack. All right, let's take a look. Okay, F is not deallocated yet because after the println we have also B, so we are calling the B function. Okay, so we are calling B function, we are loading it on the stack, and we are calling the B. Okay, so we are calling the B, this will be the last output, and then we are loading the B on the top of the stack. Okay, so we are loading the B on the top of the stack. When the B is loaded, there are no other instructions of the print lines. This means we are finishing execution of the B. We are finishing the execution of the B. All right, back here. We are moving the stack pointer back to the F, so we are going back to the F where we have finished. F after the B instruction, there are no other instructions. So we are finishing the F, we are loading it out of the stack. Moving stack pointer back to the main function, so we are back in the main. Okay, in the main function, after the F, we don't have any other instructions. This means we are loading main out of the stack. Okay, and stack is empty. We have finished our application and we are done. Okay, so that's basically it. Now let's imagine the other case. I will just do here one change. After we calling the C, okay, let's call the C. Okay, that's fine. Then call the D. In a D, we are calling A, right? So here you can see in a D we are calling A, but in the A now, I will be calling not E but a D. Okay, and now let's tell me what will happen, guys. Okay, so you can tell me what will happen now. You can also draw it. You can don't run it in your console now. Okay, don't run it in terminal yet. Okay, so let's load the C. Okay, we are starting in a main function as before, so we are loading the C. Okay, we are loading the C function here. Okay, in the C function, we are just printing out the C, so it's finished, and we are loading it straight away from a stack. So it's done its job. Oh, actually, we forgot about the main function. Main function is the first unloaded. So main function, then the C function, the C print line, this output of the C, and it's loaded back. Okay, so we are back in the main, and we are executing D. Okay, we are executing D, so there is a D function. We are loading the D function here. Okay, the D is put on the top of the stack. Okay, and now from within of the D, we are calling now A. Okay, so the A is called here. So A is put on the top of the stack. So we are putting the A on the top of the stack. All right, so A is put on the top of the stack. And from the A now, we are not finishing the A, but we are calling again D. Okay, so new stack frame with the function D has to be allocated. I don't have here any stack frames prepared for a D, but I will just rewrite, for example, this one will be D. Okay, so now the new stack frame will be allocated for the D. Okay, so we're loading again D. And now from a D, okay, we are calling the D, and you can see from a D we are loading again A. So we are loading again N, and you can now see the pattern. We are loading from the D, we are calling the A, from the A we are calling D, and this will happen forever, okay? So now we are calling the again A, so I need to prepare some A's now. Okay, so let's copy just this one here. We are calling again A, and from the A we are calling the D, so we are calling the D. From the D we are calling again A. All right, and then from the A we are calling again D. All right, and what will happen now? You can see we are going out of the stack. We are overflowing stack. If the stack has some limited memory, I told you it should be, I think, 8 megabytes. In case of the Linux, it should be 8 megabytes. So if this will happen forever, it will happen some amount of the time, you will eventually run out of the memory that has been allocated for a stack, because every stack frame has some specific memory allocated, but if you will overrun it, you will overrun the stack and the program will crash. And if you will leave the code like this here now, that we'll be calling from the AD, and from the D you will call A. Let's run it. You can see DA, 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 and eventually thread main has overflowed its stack. That's what will happen, and that's the error, stack overflow. That's that's very similar error what can happen when you're not very careful with the loops or with the recursion or the thing what we have done now. Okay, yes, that's I want to just explain you a little bit more about the stack, so you're getting more into it, so you can understand it better, you can feel it better, and yeah, with this we can continue next lecture. Any questions, ask them, and see you in the next one. Cheers.